Hello friends, I am Lakshmi Urs. Today I'll be teaching you all about graphs, which is the most important topic in data structures. So, what is this graph? Graph is a collection of nodes and edges which connects nodes in a graph. That is, now here G is equal to V, E. V is the vertex, E is the edges. Now, here A is a node, B is a node, E is a node, D is a node and C is a node in the given figure. And the edges is AB is one edge, BE is one edge, AD is one edge, AC is one edge, CD is one edge, BD is one edge and DE is one edge. So this is nothing but a graph. This whole figure is said to be graph. Now there are some graph terminologies which are used very importantly in graph. So what are those terminologies? Let's see. The first terminology is vertex. So what's this vertex? A vertex is an individual data element of a graph which is called as vertex. It is also known as node. This node, this is nothing but this vertex. So this vertex is also called as node. That's what we said. The collection of nodes and edges forms a graph. So this is nothing but vertex. Next, what is this edge? Edge is a connecting link between two vertices. Now in this figure A and B, this connecting link is said to be edge. So there are three types of edges, and edge is also known as arc. So what are these three types? Undirected edge, directed edge and weighted edge. So undirected edges, it is a bidirectional edge. That is, it is having no direction. That is said to be undirected edge. Then directed edge is a directional edge. That is, which has a direction. That is, it shows A to B or B to A. That is directed edge. Then weighted edges, it has a cost on it. That is naming sort of thing. So that is nothing but weighted edge. So now for undirected edge, AB is a edge, then it is equal to BA. Now suppose AB and BA, this will be equal for as it is undirectional. That is bidirectional. It has, like, it can go further, it can go backward. That's just nothing but undirected edge. And then this directed edges, now suppose AB is a edge, then that AB is not equal to BA. Now suppose this AB and BA is, this example, this part is undirected edge, but suppose if it had an arrow like this, then it would be directed edge. That is, A is from A it has reached to B, so that is nothing but directed edge. So these are the three types of edges, that is undirected edge, directed edge and weighted edge. Next, undirected edge. What is this? Undirected graph. A graph with only undirected edges is said to be undirected graph. Now suppose here there is no direction for this ABC graph. So this is nothing but undirected graph. That is, no direction. It can move from A, B, C, A, or else it can move from A, C, B, A. Anywhere it likes to move. That is undirected graph. Now, directed graph. A graph with only directed edges is said to be directed graph. Now suppose it is moving from A to B, B to C, C to A. So this is nothing but directed graph. Then mixed graph. A graph with undirected and directed edges is said to be a mixed graph. So in this mixed graph, we will be having bidirectional edge and directional edge, both. So that is nothing but mixed graph. Now suppose here it is A to B, then it is from B to C. Then it is given that it can either go from C to A or come from A to C. So this is nothing but mixed graph. The next thing, origin. If an edge is directed, its first endpoint is said to be the origin of it. Now here in the AB, here A is the origin as it is pointing to the endpoint. So it is nothing but origin. Later, destination. What is this destination? Destination is an edge. If an edge is directed, its first endpoint is said to be the origin of it and other endpoint is said to be the destination of that edge. Now here we said that it is the origin, then the other endpoint, as here it is the, as here A is the origin, then this B This will be the destination point, as from A it is reaching to B point. So this will be obviously the destination. So this was nothing but origin and destination. Now, adjacent. If there is an edge between vertices A and B, then both A and B are said to be adjacent. Now, if there is an edge that is A to B, then B to A, this is nothing but adjacent. What is this now? Incident. Incident is an edge. An edge is said to be incident on a vertex if the vertex is one of the endpoints of that edge. If it is having some endpoint, then that is nothing but incident. Outgoing edge. And a directed edge is said to be outgoing on its origin vertex. Now suppose it is moving from in this direction like this, then that is nothing but outgoing. Now suppose this is the outgoing, like this arrow is there pointed, so that is nothing but outgoing edge. Next, incoming edge. A directed edge is said to be incoming on its destination vertex. When it reaches the particular destination like this, then that is nothing but incoming edge. Now suppose here it is reaching like this, it is going over here, so this is nothing but the destination edge. Degree. The total number of edges connected to a vertex is said to be the degree of that vertex. Now suppose the B is getting edges from A and C, then that total number of edges coming to it is said to be degree. Now, in degree. The total number of incoming edges connected to a vertex is said to be in degree of that vertex. The total number of incoming, that is inside it is reaching, that is destination it is coming, is called as in degree. Then out degree. What's this out degree? Total number of outgoing edges connected to a vertex is said to be out degree of that vertex. Now suppose from A, one single point I am sending to A to B, A to C and A to D. So that is nothing but out degree. Then parallel edges or multiple edges. If there are two undirectional edges, that is undirected edges, to have the same end vertices, and for two directed edges to have the same origin and the same destination, such edges are said to be parallel edges or multiple edges. That means two undirected edges should have the same end vertices for two directed edges and the same at the same origin, and the same destination is said to be parallel edge or multiple edges. Then, what is this self loop? A self loop is an edge that is undirected or directed. Is a self loop if it has two endpoints coincide. Now suppose A to B and B to A. If there is a loop design, that is the arrows are from A to B and then B to A it's pointing, that is nothing but self loop. Then simple graph. What's the simple graph? A graph is said to be simple if there are no parallel self loop edges. That is, a graph should not have any bidirectional, that is A to B and B to A, that is the self loop, sorry, not bidirectional we can say, that is the self loop, that is arrow is there from A to B, then that is one direction, then B to A the arrow is pointing to A, then that is nothing but loop. So the graph which does not contain that sort of loop is said to be simple graph. Then the last terminology of graph is path. A path is a sequence of alternating vertices and edges that starts at a vertex and ends at a vertex, such that the edge is incident to its predecessor and successor vertex. Now suppose A to B, this is nothing but the path. Then A to B, B to C, then the path by which we are reaching C is nothing but the path. The way which we reach is said to be path. So this was all about the concept of graph. What all we learnt in graph was what is graph, what are the main two concepts used in graph, that is vertices and nodes, vertices which is called as nodes and edges that which is called as arc, these two main concepts, and then graph terminologies like vertex, edge, then types of graphs like undirected, directed, mixed graph, then types of edges, directed edge, undirected edge and weight edge. Then we had self loop, graph, simple graph, path, many such things. So these are all the terminologies which we in general use it in graphs. So I hope you all have understood the concept of what is graph and the terminologies of graphs very well. Thank you for watching my video. Please do hit the like button. Thank you.